Hi guys, welcome to the video on the properties of rhombi. So in this video guys, we're going to learn to apply the properties of a rhombus to find missing measures of that rhombus. So rhombi is plural for rhombus, and manufacturers use rhombi to make signs for the sides of roads. And you can calculate the measure of an angle or length of a side with at least 80% accuracy if you're doing this correctly. So, carryover properties. So just remember that because a rhombus is a special type of a parallelogram, all of the properties like opposite angles congruent, consecutive angles add up to 180, opposite sides are congruent, and the diagonals cutting each other in half all apply to rhombuses as well. So in addition, a rhombus has three more properties that for a total of 7 things that apply to it. Let's get started. The first one, and if you need to guys, make sure you just pause at any time to copy down the properties. The first property of rhombi, all 4 sides of a rhombus are congruent to each other. This means that the shape is equilateral. The second property is that the diagonals are perpendicular to each other. So, as you can see, in this rhombus, not only do the diagonals cut themselves into 2 equal halves, but where they intersect at a 90-degree angle. So all of these angles in here are all 90 degrees. And then in addition, and some of my stuff got hidden here, so I'm going to try to grab it and pull it up. It looks like I'm not going to be able to. All of the diagonals are angle bisectors of the angles that they originate from. So the angles cut these rhombuses into these these diagonals cut the angles in half. So angle 1 is congruent to angle 2, and those are also congruent to angle 3 and angle 4. And then the same thing, 7 and 8 are congruent to 6 and 5 because those angles are congruent to each other. Like when you add 6 and 5 together and you add 7 and 8 together, those angles are congruent. So then it follows that the angles across from each other are all congruent as well. And then a secondary property comes from if you add angle 1 plus 2 plus 7 plus 8, that would need to equal 180 degrees. The same way that angle 3 plus angle 4 plus angle 5 plus angle 6 would equal 180 degrees. And then any combination of the 4 angles on different sides are going to be adding to 180. So, find the measures of angle 1, 2, 3, and 4. Just going to get started on some examples right away. I know that this angle down here is 90, which means angle 1 would be equal to 180 minus 90, fix my 9, minus 63. So 180 minus 90 minus 63 leaves angle 1 is 27 degrees. I'm just going to fix my equal sign here. Angle 1 is 27 degrees. And if angle 1 is 27 degrees, that means that angle 2 must be 27 degrees. There really isn't, it comes from that last property where the diagonals cut the 2 angles in half. Angle 1 and angle 2 have to be congruent. And then since I know that, and I know that that's center angle, that's the second property of a rhombus, since I know that's 90 degrees, that means that angle 3 has to be 180, take away 90, take away 27, since those are the 2. And the reason I keep using 180, despite the fact that a rhombus adds up to 360 like all the other quadrilaterals, is that all of these shapes within a rhombus are triangles. And then so that leaves 63 degrees for angle 3, which proves another property. But so 63, 63, and then angle 4 is congruent to angle 3, so angle 4 is also equal to 63 degrees. So angle 3, I'm going to write it here, is 63 degrees, and then angle 4 has to be congruent, that is also 63 degrees. Okay, find the measure of sides AD and DC of the rhombus below. Well, they told me it's a rhombus, so then I know that all four sides are congruent. So 6x minus 11 has to equal 5x minus 7. And so if I go ahead and start adding stuff to both sides, I'm going to add 11 and then be subtracting 5x. I'm going to get x equals, and then so negative 7 plus 11 is 4. So when I substitute 4 in here and here, what I get is 20 minus 7 is 13. And then 6x minus 11, 24 minus 11 is also 13. So both AD and DC. So AD is equal to DC, and they're equal to 13. All right, another example of in the rhombus below, the measure of angle rho, RHO, so R to H to O, so we're talking about this angle here, is 72 degrees. Find the measure of X, and then use it to find the measure of HMO. So they're asking me to find this. Okay, so there's a couple important properties that I need to apply right away. If RMH is 2x, then OMH is also equal to 2x, since this diagonal cuts this into two equal parts. That means the 2x transfers directly over. And together, those angles, the 2x and the 2x, these here, have to equal the angle up at the top. So you could say that the half plus the other half has to equal the whole angle up at the top. So 2 halves equal a whole. So you get 4x equals 72 degrees. So x equals 18, which means then I could substitute this into the expression for HMO. So angle HMO equals 2x. So I can substitute that into the expression. And then so angle HMO is equal to 36 degrees. Moving swiftly along, in the rhombus below, the measure of BEC, so angle BEC is here, this angle right here, is represented with the expression 3x minus 15, find the value of x. Okay, so they're telling me that that angle is represented with an expression, but angle BEC is a diagonal angle. Since it's a diagonal angle, I know that angle BEC, so therefore angle BEC equals 90 degrees. Okay, well, angle BEC equals 90 degrees, but it's represented with the expression 3x minus 15, so I'm going to set 3x minus 15 equal to 90. Since they're equivalent, I can substitute them. So to solve for x, I'm just going to solve my equation, 3x, add 15 to both sides is 105, and then divide by 3 on both sides, x equals 35. So I use the property that all their angles, their diagonal angles, are 90 degrees. And I know BEC is equal to 90, so then I can use the expression that it is represented with as set being equal to 90, and I can solve the resulting equation. All right, another rhombus problem. In the rhombus below, the measure of RB is 2x plus 15, and the measure of RO is 50. So the entire thing is 50. Find the measure of x. Okay, so one of the carry, and then list the measure of RB and BO. So I do know, hang on, that RB equals BO. So if I find RB, which I can up here, I can work backwards and find the rest. I know, find the measure of x, that each one of these halves of the diagonal is congruent. So 2x plus 15 is 1/2. So this is from RB plus BO. So I need to add 2x plus 15 because BO is congruent and therefore its expression is equivalent. Has to equal RO. Oop, I want to take the RO part. Nope. I want to take the RO and I want to write it up here, which equals 50. So I get 4x plus 30 equals 50. So solving for x, I get 4x equals 20, or x equals 5. So I found the measure of x, and then I substitute it in, and then I can tell you that RB is 25, and BO is also 25. All right, in the rhombus below, measure of ADE, so ADE, so we're talking about this angle here, is 5x minus 8 degrees. And the measure of CBE, this angle here, is 3x plus 24 degrees. Find the value of x and then find the measures of those two angles. Okay, I do know that these are equivalent. One thing that we do know about rhombuses is that not only are the sides congruent, but they're also parallel. So through the alternate interior angles theorem, this angle here and this angle here, the two that I've marked with my dots, have to be congruent. So I know that angle ADE is congruent to angle CBE. So CBE. And then I can go ahead, now that I know they're congruent, I can write their expressions as one resulting equation at 5x minus 8 equals 3x plus 24. And now I can do some solving to get that 2x over here, because I'm taking 3x from both sides and adding 8 to both sides is 32. So x equals 16. And then when I substitute x in to either one of them, I'm going to just choose to do 3x plus 24. So the measure of CBE is equal to 3 times 16 plus 24. So it's equal to 3 times 16 is 48 plus 24 is 72 degrees. And then that means that ADE is congruent as well. So that also equals ADE. All right, and then last example, in the rhombus below, the measure of RM is 12.5 inches. And then the measure of ORM, so this angle here, is 36 degrees. What is the measure of RMO? So they're asking me to find this whole measurement right here. So if I can find this half measurement here, then I can double it to find RMO. So to do so, just logically thinking out, this angle here is 90 degrees. And it appears that the 12.5 inches they gave me, it's just a bit of extra information. It's just white noise. So I'm just focusing on angles here. So I do know that the angle, so angle RMH is equal to 180, take away the 90, take away 36. So that would make it equal to 180, take away 90, take away 36 is 54 degrees. degrees. And then if this is 54 down here, that means that this has to be 54. And added together, the angle of RMO would be 54 plus 54, or 108 degrees. So that's it for the properties of rhombi, guys. Remember that a rhombus is a parallelogram whose sides are all congruent. Rhombi, plural of rhombus, has 4 main properties, and we can use those properties to solve a variety of different problems, as you've seen. That's it for today's video, guys. Thanks for watching. See you in the next one.